Our goal is to find the slope of a tangent line to this function x squared plus 5y squared equals 45 at the point 5, 2. So to do this, we're going to use implicit differentiation. So let's zoom in here. Using implicit differentiation, what we want to do is take the derivative of each term. So we're not going to rearrange this and get y on one side all by itself. Instead, we're going to focus one term at a time and say, well, the derivative of x squared is going to be, power rule says 2x to the first power, and we could put a dx next to this, but we're going to get in the habit of not putting that because dx over dx makes 1, right? Same thing numerator and denominator. On the next term, again, power rule this time, but we're going to bring the exponent down, multiply it by the 5 in front, so we're going to get 10 y to the first power as we reduce it by 1. But our variable is y this time, so we need to put a dy dx next to this. Focused on the 45 on the right-hand side, well, 45 is a constant, so its derivative is going to be a 0. All right, next, our goal has to be isolate that dy dx on one side by itself. So thinking that first term is just 2x, 2x times 1 is 2x, I'm going to go ahead and subtract 2x, move it to the other side first. That'll leave us with 10y dy dx equals negative 2x. And then to isolate the dy dx, well, it's connected with that 10y with multiplication. So let's go ahead and divide both sides by 10y. All right, that'll put the dy dx on the left-hand side all by itself. We can reduce down that fraction just a little bit and say negative 1x over 5y on the right-hand side. Okay, from here, we were given a specific point. All right, so we've got kind of the general formula for the derivative. Next, let's use that ordered pair, the 5, 2. All right, so 5 is going to be an x value, 2 is going to be a y value. So our derivative evaluated at that point is going to be negative of 5 over 5 times 2. Get them in the right place. Or negative 5 over 10, which is negative 1/2. All right, so that's going to be the slope of the tangent line occurs at the derivative. So I hope this helps out. Sorry for the little goof, plugging in the x value in the wrong place. All right, good luck.